Okay, so just a few more ideas here that I wanted to talk about in regards to our characteristics of functions. Okay. Okay, so for example, we should be able to identify the maximum and then the minimum of a function. Okay? We know what the word maximum means, right? Biggest, greatest, most, right? We know what the word minimum means. Minimum means, okay? Smallest, least. Okay? The maximum of a function will be located where? Where will we go to locate the maximum of a function? What is the maximum of a function? It's just the what? Yeah.
The highest value.
Yeah, the highest point. Exactly right. Okay. So yeah, we have the idea of maximum value, and then we have the word, just the idea of the maximum. Okay. So if we the maximum, you could just say it is the the highest coordinate. I guess I'm going to say like vertically. Okay. The maximum value refers to just the y value only. Greatest y value. Okay. Sorry, that's smart. So the maximum of the function would be like the coordinate, okay? Coordinate. Maximum value would be the greatest y value. And so the minimum, you guys can probably figure out what that is, and it's just the lowest coordinate. Okay, again, just vertically speaking, right? And then the minimum value would be the lowest y value. Bless you. Okay. No surprises there, right? We know what the word maximum is, we know what the word minimum is, so. But do be careful, the value, right, refers just to the y value. Maximum value, highest y value. Minimum value, lowest y value. Okay, but the maximum and minimum, in my opinion, it's kind of like, I refer to those would be like the coordinate. Okay? So maximum and minimum are points. Maximum value, minimum value, those are y values. Those are the y values for those points. Okay, how about the 0, aka the x-intercept, aka the root or roots of a function. 0, an x-intercept, or a root. I put roots plural anyway. Okay. This is where the graph does what? Yeah. Where the graph crosses the x-axis. Okay. What will be the y coordinate for a 0, x-intercept, or root? Always. What is the y coordinate for a 0, x-intercept, or root? Always. It's going to be. If it crosses the x-axis, what's the y coordinate on the x-axis? 0, right? So it's always going to be the form blank, comma, 0, right? And so sometimes you don't even have to write the full coordinate because it's understood. If we're talking about an x-intercept, you can just write x equals this, x equals 2, x equals 7, right? You don't need, the 0 is kind of understood because it's like, well, if it's an x-intercept, it's the y coordinate will be 0. Just get the x one. Okay? How about the y-intercept? Okay, separate from the zeros, right? We kind of give it its own thing, so it's where the graph does what? Yeah, where the graph crosses the y-axis. For a y-intercept, which coordinate will always be 0? If it crosses the y-axis, right? Yeah, it's where the x-coordinate will always be 0 for a y-intercept, and then we'll put a little blank there for that. For a function, will we have more than one y-intercept? For a function, no. For a function, can we have more than one x-intercept?
Yes.
Yes. Right, okay, you only have one y-intercept. Okay. The last little concept here, which is like a separate thing that I just wanted to make sure we've talked about, is, okay, this other thing that's going to show up again and again. Okay, is average rate of change. Okay, it is the slope between 2 points on a function. Okay. Slope between 2 points on a function. So you just, oops, sorry, you use the slope to find, you find the slope between the 2 points on a function. Okay. So this allows us to find the average slope, an approximate slope of any kind of function, right? Before, you guys only really ever found slope on a linear function, right, on a line. Okay? But you can find a slope between 2 points on any function now. So just for example here, if, I'm just going to throw this out here. If we have our function here, negative 2x plus 3 squared plus 7, and we want to find the average rate of change of f on the interval negative 1 to 2. Let's say we want to do that, right? Well, we need our coordinates. We would need to know what is the y coordinate with negative 1, what is the y coordinate with 2. Right? Because this is the interval, this is an x interval here. How can we find their matching y coordinates? If we know what the x coordinate is, how can we find the matching y? What can we do with this x? Again, we're finding the average rate of change of this function, right? So if we know this x coordinate, how can we find its y coordinate?
Plug it in.
Yeah, plug it in. Exactly right. F of negative 1. So it'll be, let's see here, negative 2, negative 1 plus 3 squared plus 7. Negative 1 plus 3 is 2, squared is 4, times 2 is negative 8, plus 7 is negative 1. So we get the point negative 1. And then 2, we'll plug that in. F of 2, negative 2 times 2 plus 3 squared plus 7. So let's see here. 2 plus 3 is 5, squared is 50, times negative 2 is negative 50, plus 7 is negative 43. So there are 2 points, and then to find the average rate of change, that is the same as finding the what? Yes, so then times negative 2 would be negative 50, and then plus 7. Yep. Mm-hmm. Find the slope. Find the slope between those 2 points. So just use slope formula. So the average rate of change will be negative 43 minus negative 1 over 2 minus negative 1. And so that's going to become negative 42 over 3, or negative 14 if you simplify. Okay. All right. I'll write the homework up here. It's going to be in section 1-2. Okay. Starting, I think, on page 24. I'll have to check on that, though. All right. But it's in 1-2, the homework is. And we'll say numbers 1 through 12, 15, and 16. Okay. So that'll be your homework. I'll put it up on Schoology too, so don't fret if you're like, whoa. I'll also put the PDF on Schoology too.